Assalamualaikum to you students. Today our topic is acoustics and audible frequency range. So first we'll talk about acoustics. By definitions, a study of waves, vibrations and sound is called acoustics. So basically whatever you've learned till now about waves is called the acoustics. So how acoustics are produced, how they can be changed. Actually, they are the properties of waves. So how can they be changed? They can changed by changing the shape or size or emptiness or the objects present inside the room. Let's consider four types of materials which have effect on any sound wave. First, we consider flat surfaces. These surfaces don't really have any disturbance on their layers. These are completely flat. So what would they do? They would just reflect the sound waves coming towards them. Just like we studied in the reflection of sounds topic. Okay? This is incident wave. This is the reflective wave. The angle between them would be the same. So this is how flat surfaces react to the sound waves. They just reflect sound. Coming to the curved surfaces. What curved surfaces do? They do not actually reflect sound in all directions. Like in flat wave, if a wave is coming this way, it will be reflected that way. So reflection takes place all over the surface, and we can observe different kind of reflected waves all over the area. But in case of curved waves, when a wave falls on this point, it would be reflected by a certain angle which is not equal to the incident angle, and it would be concentrated on a certain point. Similarly, a wave coming along this direction would be reflected to this one. A wave coming from this direction will be reflected to this point, from this to this. So basically all these waves would be concentrated on a certain point when it comes to the curved surfaces. So what happened? The sound would be maximum here, and in the rest of the areas there will be very feeble or very low sound. Okay, now coming to the third material, which is porous. As the name suggests, it is a surface that contains much pores. So these types of materials absorb so much sound. Why? Because there are pores which have holes in it, and these holes are filled with the material itself. So these are the materials which will absorb the radiations most, the sound waves most. So what are the example of porous objects? They are cushions or blankets or curtains, etc. These objects absorb the most of the sounds. And last one is the jagged surfaces. Jagged surfaces are basically pointy and spiky surfaces which will absorb most of the sound. These are the most absorbing materials. Why? Because they have the most surface area, okay, as compared to the flat surfaces. They have the most surface area, so these will absorb the most of the sound wave and reflect very little. So if we have a room full of jagged surface, like pointy surface, it will absorb sound the most, making it more less loud and more feeble. Okay, so we can take an example here. When we see theater stage, or you can say any kind of stage like the one in your auditorium, we see that the rear part of the stage is usually made flat and is made of such material which would reflect most of the sound. Why does it happen? When a singer sings on a stage, it will produce sounds in all directions. So only this part of the sound would reach to the audience. But if we make this part a bit more reflective, what would happen? This sound waves will strike this surface and will bounce back to the audience. So, in turn, giving a louder and clearer sound. So, that's why we use reflective surfaces behind the stages. This is all about acoustics and how different kind of materials can absorb or reflect waves. Okay, now coming to the audible frequency range. The audible frequency range is simply the range of frequency which are audible to humans. This range starts from 20 hertz. Remember, this is hertz, and ends at 20,000 hertz. This is the average a human ear can hear. Okay, it starts with 20 hertz, ends to 20,000 hertz or 20 kilohertz. This range is called the audible frequency range. A human ear can hear a sound between 20 hertz to 20,000 hertz. But what about some sounds below 20 hertz or some sounds above 20 hertz? These are all sounds, but we cannot hear it. Okay? So these are termed as infrasonic and ultrasonic sounds. Any sound which has frequency range below 20 hertz, it means that about less than 20 wave would pass through a certain area in 1 second. Okay, so infrasonics are basically the high wavelength waves. Okay, the lower the frequency, the higher would be the wavelength. Remember that the higher the frequency, the higher the frequency, higher would be the energy. Higher is the energy, then lower would be the range. Higher the frequency, higher would be the energy, but lower would be the range. But because it would attenuate or it would disperse very quickly. Higher the energy, it would disperse very quickly. Similarly, in case of lower frequency, its energy would be lower, but range would be higher. That's why we see when waves can communicate in the ocean through infrasonic sound waves. Whales can communicate with each other with infrasonic sound waves. So that's why these infrasonic sounds can travel a lot much farther than any other sound. Okay? But they are low in energy and low in frequency. Similarly, in case of ultrasonics, it has highest energy and highest frequency, but they're low in range, so they cannot travel really farther in air or any other medium. And so this was all about audible frequency range and acoustics. Thank you so much, everyone.